Hello. You all hear me? Oh, there we go. All right, I got power now. I'm very excited to be here today talking about our new launch, AWS Application Composer, and how it can help you and your teams build amazing modern applications on AWS. I'm here with my colleague, Ryan Coleman, Principal Product Manager, and my name is Chase Douglas. I'm a Principal Engineer. We are part of the AWS Serverless Application Experience org, where we focus on figuring out the best ways to help everyone else build better applications. One of the really fun parts of my career has been an arc where I've had the privilege of focusing my energy on building amazing solutions for other developers to build their own great applications. Some of the learnings that I had along the way led me towards some of the realizations of how we can build better applications faster, more scalable, more secure. On two key steps along my journey in building these developer-focused solutions, I happen to architect back-end services, ingestion pipelines that had to run at high scale, high throughput. And it was really interesting to see what it took to build these services. In the first one, we architected a leading browser client-side product analytics platform. This is where we would have our JavaScript snippet that our customers, many Fortune 500 companies with high throughput consumer websites of their own, every load into an end user's browser would run this JavaScript snippet, and it would capture things like JavaScript errors or XHR AJAX request timings, page load times. And it would aggregate all that up and send it back to our back-end systems. So just imagine you've got many Fortune 500 high throughput websites loaded in browsers that each are sending gobs of data back to back-end services. So much throughput was involved in that. It was amazing. From there, I took some of those learnings of how to build agents that do a lot of meta programming and find out what's happening client-side, and applied it towards server-side use cases, like runtime application security monitoring and protection. Again, we built an agent that would run on a server, like a Ruby on Rails server, and it would watch for things like potential SQL injection or cross-site script issues when rendering HTML content. And whenever something suspicious was seen, we would report that back to a centralized back-end ingestion pipeline that our service had. So in these stops, we were building some of the same things over and over again, just for this back-end ingestion pipeline. And there'd be an API endpoint. We would try to, as quickly as possible, take messages off of that and put it onto a streaming system like Kafka. Those messages would then be pulled off, ingested by a compute layer, to then be stored into a database layer. Conceptually, logically, this isn't crazy hard to picture and represent. 4 boxes on a diagram with arrows in between. But in practice, doing this at high scale doing it securely is very challenging. I saw firsthand how much time and effort and resources were put into scaling these back-end ingestion pipelines. And these pipelines are key to the whole business working, but they're not differentiating pieces of value. They need to just work. So at about the same time I was seeing how hard it is to do all of this and to do it well, I noticed that AWS was coming out with these serverless solutions, Kinesis data streams and Lambda functions and API gateway. All of these services offload these really hard, tricky operational and security and scalability concerns. But it was still kind of hard to figure out how to architect an application built out of these components. So I went about trying to figure out how can we help developers piece these things together so that they can benefit from all of these positive ways that AWS has for building well-architected solutions. So I was working on that for a bit, and along the way, I met my colleague Ryan here, who also was thinking through similar challenges of how do we help people build better applications. I'm going to hand it off to Ryan now to talk about how he got here.
Thanks, Chase. Hi, everybody. Oh, it's much brighter up here. So first of all, I just want to say, Chase and I are so flattered that all of you came. I'm guessing many of you saw the keynote announcement this morning. We're going to spend most of our time here showing you the product, talking about the product, taking your questions. But like Chase, I wanted to share a little bit of a personal story on my background, how I arrived at meeting Chase and going on the journey with him, because it kind of informs a lot of how we've approached building the product. And hopefully that helps you understand our motivations and the product itself. So how many of you, and I'm not going to be able to see your hands, so maybe you shout out a name, last decade, the configuration management wars. Anybody get involved in that? Nobody. Well, as I said, can't see your hands. But I was at a company that was at sort of the forefront of that movement of configuration management, specializing in automation. This particular company's been bought by one of the most old school version control systems in the world. I'll let you figure out which one it is. And during my time there, I got to meet so many IT professionals in the largest organizations on the planet and some of the scrappiest, most interesting startups on the planet. I just completely lucked out because I was a tinkering sysadmin. I come from an ops world. I was running a scrappy infrastructure at Penn State University and then found this automation framework to go and get better at my job and scale out the services we were offering students, faculty, and staff. And that got me the best job I've ever had. And meeting all these IT operations people, mostly sysadmins, DevOps engineers was starting to become a title at that point. So many of them were being confronted with this automation framework with, I am running this data center, and how do I automate all of it? My business is asking me to move faster, get more services that are highly scalable and resilient in front of my developers. And this was a point in time, if you participated, where a lot of sort of shadow IT was starting to happen, where operations teams weren't moving fast enough for developers. They were starting to pick up purchasing cards on AWS or other cloud providers, and were just starting to roll their own VMs on EC2 and other services. And this presented all sorts of business challenges that you can imagine. So the real accelerator for picking up an automation framework, and you could pick from Puppet, Ansible, Chef, any of these, they were all just doing the same job of expressing a reusable set of infrastructure as code that you could then build and build and build around and scale your knowledge and empower the teams around you. But so many times I started in pro services at this company and was able to get into a room and teach people how to use the software. And I realized a lot of the time it was a development team and an operations team meeting for the first time because I was there. And they're asking me how to solve their cultural problems. And I'm like, I'm just here to help you understand this framework. And you realize that I actually can't just come and explain to you this framework. I have to teach you Git. I have to teach you version control practices. Some of the developers knew it, and because they're not talking to the ops team, they hadn't shared that knowledge. So you're trying to create connections, something that will last beyond your pro services engagement. But so much of my time was actually just helping people understand this is how you think about a text document that is going to be versioned through this stuff. Now, some people had bash scripts, but they were storing it in like RC or something. Like they weren't really using Git yet, because that wasn't yet a thing. I'm talking like early 2010s. So I really took a lot away from that experience, because I learned that like you can't just say, here's this powerful framework and just go. You have to actually bring someone along on a journey, and that takes time, it takes motivation. So many of these people I was paid to come and train were actually adversarial towards me. They thought we were gonna take their jobs because somebody decided to go do this framework. I see that kind of in the serverless world now too, and I always find that to be peculiar, because an automation framework for VMs, serverless managed services, there's still plenty of work to do. Right? You're just changing where am I spending my time and what am I putting my effort into. And so that thought process has led me to the learning curve is too steep. If you're saying there's great benefits to this thing, whether it's automating VMs or operating managed services in a distributed cloud, both of them require, I've got to learn those services that I want to use or provision or automate. I have to learn how to integrate them together. I have to learn all the frameworks and sort of tool chain around that. And so for like virtual machines, if your whole goal in life was to log in via SSH and then run a bash script, that was your DevX. But an automation framework required you to be like, well, you actually have to learn about a different server that you're gonna run a command and execute your code on. You're gonna have to install an agent, run a command on that agent, learn all new CLIs, and on top of that, learn Git. On top of that, learn version control practices. On top of that, talk to your devs. So you can see that like it stacks up. And so I think like when I'm approaching Chase and like starting to learn about what serverless is like and what are the challenges there, the thing that got me really excited was, oh, there's this flip side of the coin where instead of building up managed services on your own VM fleet and spending all your time figuring out how to get those built up and operated at scale, you could choose at least some of those services to rent from a cloud like Amazon and get the sort of speed of that quality service. But there's this huge challenge. You still have to learn all that fundamental stuff. The same stuff I was seeing in 2010, I'm seeing now. How many of you just love working in CloudFormation, right? And I'm sure there's a couple of you, and that's great. And so I want you to understand that when we get to the demo and when we get to the Q&A, I'm not trying to say you shouldn't have to care about CloudFormation or any other ISC framework anymore. But when you go back to your office, look around and see how many people in my room are as good at this as I am. And if they're not all as good or better than you, ask what's stopping that. It's not like they're dumb. They've got a lot going on. They've got a lot to learn. And if serverless is also the thing they're learning, the IC of it is a really painful challenge to also learn. So that's kind of what we're going on here. That giant YAML document, and I should say, we've invested so much of our energy launching this thing that you're about to see and that you're about hopefully have played with already today. We didn't put a whole lot of energy into the slide art, so forgive me. I asked a computer to generate this for me. I asked it, give me a big YAML document with a puppet looking at it. It's kind of YAML. I see indentation, I see a lot of text, and I'm very proud of it. And that's what I've encountered since I joined Chase and started down a serverless journey and learning what does it take to operate this at scale. It's a very different story to go through a management console and click through and go through your sort of hello worlds and understand the services than to actually try to operate them and actually build a development loop around it. There's gonna be, and it doesn't have to be just YAML, right? I'm picking on this, but any infrastructure as code framework, whether it's sort of a procedural, code-driven experience or a declarative, sort of syntax-driven experience, you still get thousands of lines of stuff that you have to keep in your head, manage, and again, you may become the pro. But what happens if you hire a new marionette to join your crew and they don't have that skill set? How long is it gonna take them to be productive? And maybe they're coming in with a very specific skill set and you want to leverage that skill set, but they spend the first 3 months becoming as good as you at CloudFormation, right? That's not the point of this, right? So what we're trying to do here is reduce that curve. I have a lot of experience doing that with infrastructure as code in the VM world. Chase has a ton of experience doing that with the serverless world. So together we've kind of figured out how do we blend this and make this easier for folks. I'm going to show you a demo. Chase is going to come up and make a couple more points. And Chase, I'm going to set up my demo while you do that.
Yeah. So we're starting to bridge into what can we do with serverless. And many of you probably already know and have been hearing a lot about the power of serverless. But just to quickly recap, some of the super awesome things when you go in this modern way of building applications, it means you don't have to provision or manage servers. I heard Eric, one of our DAs, he said, you don't treat servers like pets, you treat them like insects. They are all over, and they just kind of talk to each other. And they kind of, everything just kind of works. Scales with usage. You pay for the value. So when you're just getting started, you're doing some POCs, it starts out at a small cost. If anything, there's a pretty decent free tier for much of this. And over time, unit cost dynamics, as you grow, your costs grow with it. So your business stays in sync with what the value is that you're getting from our platform and that you're delivering to your clients or to your customers. And lastly, with the right tools, it's easier to architect for scale, security, and operations. If you think of the Lambda compute model as an example, you're getting an isolated sandbox. You're even getting a solution where it's protecting you in some ways from the possibility of multi-threaded race conditions. So there's lots of different interesting implications of serverless that have helped people build better applications over time. But to achieve this, it's not always easy. We've heard from customers who've said, well, I like serverless. Maybe I understand how to do serverless, but I'm having to teach my team how to do serverless. We're having to engage with other people to provide learning materials for serverless, figure out how all this works. As with any architecture paradigm shift, new tools and techniques are required to become efficient. Serverless requires a few things. The first thing that we need to figure out is infrastructure as code. There are so many resources that you have to manage in an application. The only sane way to do it is to automate how they get provisioned through infrastructure as code. But this is not exactly straightforward. As Ryan was saying, this is best practices for a well-architected S3 bucket in CloudFormation. It starts out simple that you're saying I want a resource of a type AWS S3 bucket. But if we want to make sure that everything is encrypted by default when it's at rest inside of the bucket, we need to add some more configuration. If we want to make sure that it isn't open to the public, we need to add some more configuration. If we need to make sure everything is encrypted in transit, we need to add another resource type. And it keeps going on and on and on off the end of this screen. So even somewhat simple resource types require a lot of knowledge about how to configure them well. Once we have a sense of how to build CloudFormation templates, we now need to have an understanding of architecture patterns. Thankfully, we've got some cool resources. This is the Serverless Land Patterns Collection. It's a great site. You should check it out. It's at serverlessland.com. There's a lot of learning materials there. One of my favorite parts of it is you can go and look at this collection of patterns. You can even filter it by the types of resources and architecture patterns. If you're like, well, I want to use an API gateway for an endpoint, and I want that to trigger a step function state machine, this can tell you what that looks like, that it's even possible to do, which is a key question sometimes. Can I do X, Y, or Z? And these patterns can help you understand all the different ways that we can architect our applications. But once we understand what these patterns can look like, we now need to understand how to configure all of the important details for every one of these resource types and how they're related to each other. And so we have some great API reference docs. This is the example AWS SNS topic configuration documentation for CloudFormation. And it tells you everything you need to know about every property. But this is still a huge amount of information for one resource to go and learn how to configure every little bit. And lastly, once you've gotten past all of that, you've figured it out on your own. Now, how does your teammate, who maybe sits next to you, has been working on something else for the past week, how do you communicate to them what you've done? How do they understand how this all fits together? So we build architecture diagrams. This is just an example one off of our solutions library. And it's great. It conveys a lot of details that are very important. But next week, we've added more stuff to this. So are we going to go and update this diagram? Well, we should. But who has diagrams right now they're aware of that, like, it's in my repo, but it's out of date? I know it's out of date. OK, so that was almost everyone. Everyone who didn't raise your hand, you just didn't realize that one of your other engineers added something to your template. You got to catch up. Eventual consistency, right? So this is where AWS Application Composer comes in. Application Composer helps us in a number of key ways. As you're building your application, you can drag and drop using an intuitive workflow to add resources to new or existing projects, to connect them. You can do this to build APIs, to build background batch processing systems, event-driven workloads. One of the really fun things is you're starting, as you'll see in a moment, you've got a canvas as a 2D canvas. You're really being able to connect things as a graph. It gives a lot of power to understand how this is all put together. As you're doing this, as you're wiring things together, you're generating well-architected configurations. Just like we saw that S3 bucket configuration, as you drag an S3 bucket into the canvas, with Application Composer, it is scaffolding it with those best practice defaults. And as you do this, and as your teammates do this, teams of engineers begin to learn infrastructure as code. They begin to learn how this fits together. As we were developing this product, and when we had it in hands of some people who gave us feedback early on, they would tell us that things like CloudFormation were daunting to them. They actually might have been afraid to even go off and try to figure out how it worked. It was like a wall of text. But as they dragged and dropped resources onto the canvas and they wired things up, they could see how that changed their infrastructure as code, and things would start to click for them. This iterative process that they could just keep repeating enabled them to see, as they extended an application, how this all hangs together. And that enables teams to communicate more effectively as they are building their modern applications. So I'm really excited. Ryan gives amazing demos. And we get to see some of that now.
Thanks, Chase. All right, he's setting expectations high, but let me switch over to demo and see what I can do. So maybe some of you have gone around and played with this today. I'm going to show you a couple different things that you can do with it, kind of scaling up the complexity of the app that you can build or visualize and import with Composer. And it's sort of like a hint of what's going on. But I'm going to try to explain to you some of the thinking, some of the things you may have missed if you played around with it today. I'm going to try not to shout at you. First thing to know, I'm in dark mode here. We have dark and light modes. It just goes with the canvas, or sorry, the overall console UI, dark mode or not. But I'm not a developer. I'm a product manager. I've been looking at metrics dashboards all day. I'm wearing a collared shirt underneath my hoodie here for the business meetings I had. So don't judge me. I'm not a developer. But my team wouldn't let me do this in light mode. So when you come in to create a project, you can start from scratch. You can bring in an existing template. I'm going to show you how to do that in a few moments. And then I'm going to show you what connected and unconnected means. But first, I want to kind of iterate on the points that Chase just made about how the core workflow happens. You've got some resources here that you can drag and drop onto the canvas, for instance, an S3 bucket. On the right panel, there's some options you can configure for that bucket visually. It's not all of them. It's not trying to be all of them. If you go back to the talk track I had earlier, we're trying to make this more accessible for someone who's learning this for the first time. You may go and add more properties. For instance, if I switch over to the template, there's a lot going on in here, and we're not trying to expose every knob and whistle in the properties panel, because this is meant to give you this gradual learning of, if I just want a bucket, we're going to try to give you a bucket that has reasonable sane defaults, that's not going to get you in trouble. Corey Quinn's not going to give you an award for having a publicly accessible bucket on the internet, at least not through the default configuration for a bucket in Composer. Right? Those are the kinds of things we're trying to do here. You can come in and make edits to this configuration, but the visual properties editor is going to give you some of that. For instance, if I turn off public access, the template itself will be rewritten here. You may have missed it here. It's pretty quick, but there's a bucket encryption. If I go back to the canvas, switch to template, add on the access view, we add in the public access block configuration. So over time, we'll figure out which ones of these are helpful, which knobs you want to like quickly tune, but that's an example of what we can do with a bucket. So let's say you want to connect this bucket to something. Let's try function. Function, similar deal. You have a bunch of properties in here. Buried down here a little bit is function URL, so you can like create a function URL and invoke that from here. If that's something that you've wanted to play around with, we make that pretty easy. It's just at the bottom. But as you kind of draw these configurations, you can see that this port lights up of what you can connect to. So let me try to bring in something that maybe you couldn't connect a bucket to. These things light up for you. And once I've made this connection, we think of connections, at least today, as being one of three kinds of things. We're going to connect IAM policies for you, we're going to connect event subscriptions for you, and we're going to connect environment data between resources for you. That could expand over time. This is sort of a flexible connection concept, and it's contextual based on the pairings that you're using. So we're trying not to make you think about it first. We're trying to just take your intention and apply it. So in this example, I can go back into this template view, and I can see that my function has an event set up for it. Let me scroll this up. Actually, maybe I'll make that a little bit bigger. That kind of configuration. Now, this is another scenario where we're not applying all the bells and whistles here. For instance, we've just defaulted to object created and removed. You may want to add a filter to this. Right? And you're going to see later in the demo, anyone can take this template in your own IAC. Those of you who are experts in CloudFormation, you could go add an event filter here for the types of objects you want to trigger an event on. When you bring that back into Composer, it'll be respected, it'll be honored, and someone can come in and make tweaks right here in the editor if they want to. Maybe over time, we'll add in some graphical settings for filters, but the idea is to help you kind of graduate in, make you some default configuration, and make experimentation pretty easy. So for instance, I could disconnect this, and when I do that, all that configuration is undone. So this is kind of a surgical read, write, edit system. It's not like rewriting the template from scratch every time you make a change. It's parsing and editing as you go. So I could connect this function to the bucket, and now I have a different configuration in place. Still the same bucket, but now my function has the environment variables. I said that was one of the three cases, and the IAM policy. Right? So now you've seen all three cases. So environment data you would pass around, IAM policies, those are usually based on SAM policy templates, but not always. and environment data and events. And we try to wire in some other things too. So log groups, X-ray, that kind of stuff. So that's a simple example. We can zoom out here. We could add other things. And the whole idea here is to make this simple to say, oh, actually, I want the bucket to work with a queue. And I don't want this function over here anymore. I want to move all this over. I want to add in a function. I want to connect it to a subscription. Oh, I've heard about dead letter queues. How do I do those? Just wire that up over here. Hit arrange. Right, that was like 30 seconds. So the idea here is this may not be the final infrastructure as code that you take into production with you, but it sure as hell is going to be a good start. Right? That's the idea. So I can scroll down here. I see I have a queue. It's configured for these redrive policies that are, again, just some sane defaults. We've got the queue policy. We go down to the function, the events for the queue. Right? And so what I was saying earlier is, like, as you're approaching serverless, you may understand, oh, I understand the DLQ pattern. I know I need to get it. You may go to that resource Chase mentioned earlier, the serverless land patterns, and go and grab one. But this lets you sort of incrementally see the progress you're making. As you draw each line, you can kind of go and see what infrastructure as code is there. If you decide you want to get rid of the SQS queue and try out an SNS topic and connect your function to the topic, you can just do that. And not worry about like editing the CloudFormation. This, for me at least, again, not a developer, early days of learning serverless and writing all this CloudFormation, I'm pretty good at IAC. But the syntax is only half of it. It's also all the actual properties you need to fill in. And a lot of the time, I'm sure you've experienced this, you think you've swapped out one resource for another, and you run your CloudFormation deployment. 10 minutes later, it tells you, nope, you suck at this. Here's some vague information for you to go and solve it. And it's trying to be helpful, but it took a while to tell you that, and you have to go and do it. And then you repeat the loop. Right? It's not the end of the world, but it's annoying, and we're trying to speed that up. So let me show you something else. As I said, you can start from scratch, or in this case, I'm going to load an existing project. Loading an existing project presents another option. You may have noticed this if you played out today. We have this connected and unconnected idea, because you may be asking yourself, how do I get my template out? How do I get a template in? Where's the version control integration? Well, the idea we had for this is not to have, at least initially, any version control integration. Because it turns out, all of you working with this stuff, especially if you're doing a serverless app, you have version control already. You have a project already. You may be starting a new one, but all of that's on your local workstation already. And you have tools on your local workstation, like your IDEs, like your SAM CLI or other deployment tools. The thought we have here with this connected mode is to literally connect the AWS Management Console, this particular app anyway, to your local file system, so that you can get all the benefits of this visual canvas without losing any of the benefits of your local file system and the tools you're using on it. So I'm going to show you that. This is just standard. I'm on Mac here, so it's just a Finder window. We're outside the app at this point. I just choose where I want to go. I have this sort of folder already chosen. Then you get two browser-based permissions prompts. We're using a standard browser API. There's a difference in API support between Firefox, Safari, Chrome, and Edge. So you're going to see sort of different capabilities on those browsers. We're just following standard browser APIs here. In this case, I'm using Chrome. It has the most features. This is giving session-based permissions for Composer to access files in the folder that I've specified. And if you're curious, in the developer guide for this product, we go into some more detail about the security posture of this, the APIs we're using, reference documentation. So there's more here you can dig into. But for now, just know that it's a session-based credential. So I can view. That lets me select a template. Maybe I have multiple. In this case, I'm just choosing template.yaml. And then one more permissions prompt. This one's giving me edit access. Technically, this browser API lets you do one and not the other. If you want to use Composer, you got to give it both, but there's two prompts. So I'm going to say, yes, you can save changes for me, and it loads this template. I know that was a long walk, but now I have an imported template. In this case, I'm going to show you a larger one in a moment. This is a pretty simple architecture. You can imagine building this from scratch. This happens to be a demo app that Chase wrote and you can get to from the homepage of this app. But the point here is that I'm connected to the file system. I've got this Visual Studio Code open to that template already. So now I'm going to come back over, and I know this is going to get small. I'm sorry about that. But I'm just going to split screen here because I want to show you how this works together. So I'm going to scroll it over until everything starts to minimize. And I'm going to show you, I'm going to open up this function here. And I've got, let's see, I'm looking at list item. Let me find you list item here. I'm just going to search for it. There we go. So over here, I have a function named list items. On canvas on the left, I'm also looking at list items. And just to prove the point, I'm going to change the memory size to 2048. And I'm going to save that in the visual editor. Now, the doc's in my way. OK, and when I save that, you may have missed it, but it updates the code here, right? And the same thing back and forth. 1024, I hit save. You can see the little pop-up in the bottom. It's been auto-loaded, comes back in, and it's made this change, right? And the point of this is that it's a bidirectional live sync. It may take, a microsecond. We're making a transaction over the cloud here, but because of that API, we're able to work directly with your local file system, and that opens up opportunities for you to use the canvas for what it's good at, drawing out new resources, connecting those resources, experimenting with new services that you haven't experimented with before, but then use the IDE for what it's good at. I'm just going to keep going on that same example and say, oh, the memory size for this particular architecture should actually be 2048, and I want every one of them to update. OK, now all of them are updated. Right? So we think of these as companion tools, and it doesn't have to be Visual Studio Code. It can be any IDE of your choice. So I know you're going to ask me the question, when is it going to be an IDE extension? We might provide those someday, but we wanted to start here first because now you don't have to pick which one we did first. Whatever IDE you have on your file system, it's going to work. Also, in the background, let me make this a little bit bigger and see if it kept working on the Wi-Fi here. I have a CLI tool running. In this case, let me scroll all the way up. And I know this is a little bit small. Actually, let me just pop this out, because we don't need that anymore. Anybody familiar with the AWS SAM CLI? Any happy users? I'm also the PM for that, so be kind. SAM Accelerate, if you haven't seen it before, the CLI invocation is SAM Sync, but you'll see it on the internet as Accelerate. This tool is helping you kind of accelerate the development loop between your local functions and or your CloudFormation template. And I'm pairing it with Composer. We didn't do any extra work. This is just an example of how these tools can work together. So no changes were needed to this CLI to work with Composer. I just told it I wanted to sync. I gave it a stack name I wanted it to provision. I told it to watch. That's an important bit. Watch just says, check the file system of this project directory for any changes and synchronize those to the cloud when there are. And there's a lot of feedback here. It went and built the functions. It did an initial deployment. This was the thing I did while Chase took over again. So it spun this up in real time. I wanted to do that while my credentialed AWS cloud is fresh. And then this is when I made that memory size change. So as soon as I hit save in my IDE, I see the change reflected in Composer. And because I'm running SAM Sync in the background here, that's already synchronized and updated. And I'm sorry, I activated that. And down here, there's more functions being activated and updated because of that change. So that's the kind of idea. You don't have to use SAM CLI. You can use any of the CLIs or other tools of your choice. But the idea here is that because we're integrated directly with the file system, this is just going to work for you with the tools you have. And if you haven't checked out SAM, try it out. Try Accelerate. It's very fast for your Lambda updates, by the way. Because it's meant to be a developer tool, SAM Sync will take any updates you save to your Lambda function and immediately synchronize those against the Lambda API. No CloudFormation loop, so it's millisecond. And that's meant to help you quickly get the code for your app running against live cloud resources, which take a little bit longer to provision. But hopefully I'm demonstrating here that as I go back to Composer, let's say I want to add in a new Dynamo table, I just draw this on the canvas, and the deployment's happening. Right? And I know that seems small. Right? I could just go and run the deployment again. But because these tools are paired like this, it just makes everything go a little bit faster and make it a little bit easier. And I can focus now on what am I doing with this Dynamo table instead of provisioning the Dynamo table. Now, there's a few spots in the UI where we're going to provision something that's not yet ready to deploy. Like if you bring an API gateway in, but don't yet connect that default route to a function. We're going to add in a flag to help you understand that. So just be aware that there's a couple situations like that where you need to take an action before it's deployment ready. Otherwise, everything you do in Composer is ready to deploy in AWS Cloud. So you can pair it with tools like this, so you don't have to think about it. In your development account, you can just provision and go and get work done. All right, so let me show you one more. I'm going to load an existing project. This one is going to be a trivia app. Same flow. Oops, I repeated it. All right, this one's much bigger. This is a little bit of a riff on a public sample called the Serverless trivia game. It's a multiplayer game. You can do trivia with others. I haven't provisioned it, so we can't play together today, but maybe sometime. The point here is that it starts to become much more of a real architecture, and the diagram gets much bigger. So I'm going to show you a couple extra features we've added to Composer to make that a little simpler. One of them is this list view. So as I organize resources into groups, which I'll show you in a moment, you get this little picker. And if I zoom in a little bit more, this will be more useful. Let's say I want to check out this question put function. As you click through, this is like the closest we have to a mini map here. Oh, I want to see the Dynamo accelerator. I'll click over and see that cluster. Right, same thing down the line. So these are the group names, and then the resource titles, the logical IDs. So you can see this group action here that lets you go and create groups. So let's take an example here. Let's say for some reason I wanted to take these four and add them and group them. I can then create groups in groups. Right? So now I've got a group within a group in a much larger diagram that I might do because I want to have, let's say DAC security. I'm making this up as I go here. But now you have this organizational nesting. You can click around. You can see these different things. So what is a group? It is benign. It's there for the visual. We're not provisioning an AWS resource group or anything, though I'm curious to hear if you'd like us to. If you'd like us to sync these up, that's cool. We might do that. But for now, they're just for the visual organization aspect. Because we want, especially you scale up to an application that looks more like this, it can be a lot of resources. And so organizing them and having a map to look around, and as you zoom out, like, oh, that's the avatar service, that's the trivia logic service. I understand it's gonna be hard to read from the back, but the idea is you start to have these titles that you can key in on. And as Chase was mentioning earlier, this may be handy for you, but if you go through the work and organize like this, it's gonna be very handy for the next person coming in. And it's a live diagram. So as I come in, I might go back to this group I have, go back to the resources picker and say, I need to add a bucket into this group here. And I can just drag that in, it'll be organized into the group, and I can go and continue to work with it. So how is a group persisted? In the template at the very bottom, and this template is gonna be large, hopefully I'm proving the point, we're over 1,000 lines of code here. Who wants to hold all of that in their head? It's very verbose. So that's hopefully what we're gonna help you with. The groups are all persisted in this metadata. This is not metadata we've added. There's no new backwards incompatible change to CloudFormation or anything like that. This metadata keys existed for a while. I think it came in with the CloudFormation Designer product. It's there, we're using it. We're adding in this AWS Composer's group key. And then within that, we're managing mappings between logical IDs and the group names. And we're doing that so that you can walk away with this template, you can go through your peer review, you can make any changes you want to the template, come back in, the groups are persisted, of course. I'm anticipating one of the questions is, please don't ruin my diffs with this kind of stuff. We're trying. So we're trying to minimize the amount of syntax we're adding that's not relevant to your CloudFormation deployment. This is our concession to make sure that you get these visual groups and you can organize it. We think the diffs are going to be pretty minimal because once your groups are established, they're not going to change much. So that's groups. You can see we have these lines moving around. These lines, again, show those connections, one of 3 types. You can find it by navigating around here to the blue. I think we might make it easier for you in the future to be able to pop between these. That's something we're looking at. But now I can see my API has all these routes. And et cetera. right? So that's the rinse and repeat loop here. For even a large architecture, all the same characteristics apply, and I can go and quickly add in new content. Now, I want to come back to some of these resources that are read-only. So on the side here, you can see this resource picker is not super long. And if I search for Dynamo Accelerator, it's not in here. Or DAX, or whatever the term would be, it's not in here. Now, I want to note, there's this feedback button here. We will read everything you post into that thing. And so especially if you're like, I would really like you to help me build X, tell us what that is, use this button, or tell us after this, and we're going to prioritize a new resource support. But for now, we want to be able to support loading everything you have. So the treatment is what we call read-only. In other words, we're not building the configuration for you, but if you've done that work or you've brought in a sample from another location, we're going to render that as best we can. And so in the right side there, you'll see we're attempting to parse out, in this case, we have a managed policy. We pull out the logical ID for the card, and you can browse the code in its snippet form. So you don't have to browse around the template to see what is this thing actually. We're going to improve this over time. I think a logical request many of you asked me today is, can you put the resource on there, both the type and the service icon? Great, we're going to look into that. But that's the idea. You can take anything that you can express in CloudFormation, we're going to visualize it, you can organize it into groups, and we're going to expand the ones you can build with over time. Now, let me refresh out to a blank canvas and show you one more thing, and then we'll take your questions. All right. So the thing I wanted to show you is about defaults. You may be about to ask me, how are you going to bring in my own organizational defaults? And I don't have an answer for that. This is a preview. All right, we're just getting started. We're trying to catch out some of these ideas. So I want to hear from you about how you want your organizational defaults to go in. But one of the things we're putting in here is trying to add an engine to understand certain choices you make. For instance, the default runtime for a function is Node 18. If you're not a Node 18 shop, you may go through and choose a different runtime. Let's say you're Python 3.9. You save that. Great, that's one function done. The next function you add in will not be Node, it'll be Python. And if you import a template and the majority of those functions are in the Python 3.9 runtime, new functions will be Python 3.9 runtime. So there's a couple little things like that in here. It's not going to be all your sort of defaults brought in, but we're trying to figure out how to teach this app. Okay, people are doing some things repetitively. How do we just accommodate their needs? And yeah, there's a couple little things like that in the app.